Hi, my name is Philip Ng Hong Ming, and my metric number is 01DKM21F2011. Introduction of Integration. Integration builds an understanding of the integration applications, especially in calculating the areas and the volumes of bounded region. In maths, integration is a method of adding or summing up the parts to find the whole. It is a reverse process of differentiation, where we reduce functions into parts. This method is used to find the summation under a vast scale. Calculation of small addition problems is an easy task, which we can do manually or by using calculators as well. But for big addition problems, where the limits could reach to even infinity, integration methods are used. Integration and differentiation both are important parts of calculus. The concept level of these topics are very high. Hence, it is introduced to us at higher secondary classes and then in engineering or higher education. Now, we will talk about techniques of integration. There are several techniques of integration, which is indefinite integrals, defined integrals, integrals of trigonometric, integrals of reciprocal functions, self-integrals of exponential functions, integration by parts, integration of partial fraction, area of a bounded region, and lastly, volume of revolution.
While integrations can be used to find areas, volumes, central points, and many useful things, it is often used to find the area underneath the graph of a function and the x-axis. While of course there are integration rules, and some of them which are constant rule, power rule, algebraic function, linear substitution, reciprocal function, area under curve, and volume under curve. As for example of application of integration in real life, where typically it is used in industry types, where this calculus is used. Like in the field of engineering, engineers use integrals to determine the shape of building constructions or length of power cable required to connect the two substations, etc.
Today, I would like to solve some questions about integration. There are a few questions to solve. Let's look at it. Given the graph of the curve with equation y equals x squared minus 5x minus 30 and the straight line of this graph is y equals negative 2x plus 40. First, we need to solve this equation. This equation is about the point of intersection A and B between two lines y equals x squared minus 5x minus 30 and y equals negative 2x plus 40. First, let y1 equal x squared minus 5x minus 30 and y equal negative 2x plus 40. Let y1 equal y2, then it informs x squared minus 5x minus 30 equal negative 2x plus 40. Then we need to rearrange it and do the plus minus action and factorize it to x equal to 10 and x equal to negative 7. Then we need to substitute x equal 10 and x equal negative 7 into y2 equation to get the point of A and B. Thus, the point of A, x is negative 7 and y is 54. For the point B, x is 10 and y is 20. The next question that we need to solve is the intersection point of C. We need to use y equal negative 2x plus 40 to solve this question. Substitute when x equals 0 into the equation and we will get y equal 40. And the point for C, x is 0 and y is 40. The last question is the area under the curve for the region bounded by the curve at the axis. First of all, we need to know the area is equal to integrate y2 minus y1 and the second point x is 10 and the first point x is negative 7. Then we need to do in the plus minus between y2 and y1 and we will get negative x squared plus 3x plus 70. Then we need to integrate it by using the integrate formula. Integrate x power n dx equal x power n plus 1 divide n plus 1 plus c. Then we need to substitute the 2x into the equation and solve it. Lastly, we will get the answer of 818.84 units square for the area. Summary. Integration is the reverse of differentiation. Integration is the calculation of an integral. Integrals in math are used to find many useful quantities such as area, volume, displacement, and etc. When we speak about integral, it is related to usually defined integral. The undefined integrals are used for antiderivative. Integration can sound like a scary concept at first, so I like to think of it just as the process of taking an antiderivative. As we already learned, finding an antiderivative is the reverse process of finding the derivative of a function. That breaks things into pieces. To find the derivative of a simple function, we need to multiply the variable coefficient by the same variable exponent. Then we need to subtract 1 from the original exponent. This is the power rule. Now, to find the antiderivative of a function, we need to complete this process backwards.
I climb every mountain and swim